Hello everyone, am I audible to all of you?
Yes, sir. Hello, sir. Good evening, sir.
Yeah, good evening. So let's start today's session. We're starting right away. Can you see my slides or screen?
Yes, sir.
Okay, thank you. Thanks a lot. So a very good evening to all of you. So today we are going to have our second last live sessions for problem solving session for this biochemistry course. Here we'll be taking a few problems and then solving them. So let's begin with the first problem, or else should we wait for others? Can start, right? Yeah. So first problem we have, identify the incorrect statement with respect to biosynthesis of acetyl coenzyme. So the first option it says TPP act as a nucleophile and attacks the ketocarbonyl in pyruvic acid. B option says during decarboxylation the thiamine moiety acts as the electron sink. C option says NAD plus act as a coenzyme during the oxidation of dihydrolipoate to lipoate. Reduction of FAD to FADH2 involve an intramolecular nucleophilic attack by sulfur from dihydrolipoate in one of the steps. So the question is basically from the mechanism of biosynthesis of acetyl coenzyme. So anyone wanted to answer this question? Anyone of you? Any guess? Okay, let's say the synthesis biosynthesis of acetylcoenzyme. So in the biosynthesis of acetylcoenzyme, so this is from the carbohydrate will get converted to glucose, from glucose to this acid, acetyl acid, and then coenzyme one, and coenzyme one is a thymine pyrophosphate that is called TPP. This is thymine pyrophosphate, and coenzyme 2 lipoic acid, and coenzyme 3 FAD. So here they have talked all about all the steps. So the first step is TPP act as a nucleophile and attack to ketocarbonyl group in pyruvic acid. So for that we need to know the mechanism. So this is the steps involved in the synthesis of this acetyl coenzyme. Here is the thymine pyrophosphate. This is a thymine group which has the phosphate. This is a lipoic acid, and this is a flavin adenine dinucleotide. So this is a flavin group. If you remember, this is a flavin group. This is adenine, and this is the dinucleotide of that. This is flavin adenine dinucleotide (FAD). So it is asking that the TPP act as a nucleophile and attack the ketocarbonyl group in pyruvic acid. So how this mechanism, how these three coenzymes, coenzyme 1, coenzyme 2, coenzyme 3 involved in synthesis, and what's the mechanism. Okay, so let's see. So this thymine pyrophosphate first, this negative charge on this carbon, it will attack on the carbonyl of the acid, and then this this will liberate the one CO2 molecule, and this then it will generate this nucleophilic center. Again, this nitrogen one pair will push, and then it will attack to the this disulfide bond of this lipoic acid, and this will cleave off. After this, what will happen? After this, what will happen? This lipoic acid will get connected to the this carbon, and this will be OH. Then H will release, and it will neutralize this charge and break this CC bond. Then you will have a acetyl thiester bond with the lipoic acid, and then thiester bond of the coenzyme, acetyl coenzyme, it will come. Thiol group will replace this thiester bond, and it will form this acetyl coenzyme. And again, this lipoic acid will get reduced by FADS2. So you can see this FAD, it is oxidized and this is reduced. So these two, this will get reduced and this will get oxidized to get FADS2 and this oxidized form of this disulfide. So here the mechanism written already. This will attack on this thiol group will attack on this carbon. It will have negative charge. Then this again another thiol will attack on the sulfur. It will release this FAD and lipoic acid. So this is the mechanism over here. So we can see the option C. What is the option C? NAD plus act as a coenzyme during the oxidation of dihydrolipoid to lipoid. Okay. So multiple coenzymes are involved here. So the TPP act as a nucleophile and attack the ketocarbonyl of the pyruvic acid. So you can see the TPP act as a nucleophile and attack to the carbonyl of this pyruvic acid. So this option is correct. During the decarboxylation, the thymine moiety act as an electron sink. So decarboxylation, see, this is the decarboxylation next step. This hydrogen electron is coming here, and then it will come there, and this it will get dissolved with the positive nitrogen. So it act as a electron sink. So this option is also correct. Then reduction of FAD to FADH2 involve in intramolecular nucleophilic attack by sulfur from the dihydrolipoid in one step. So reduction of FAD to FADH2. So you can see here this is FAD and this is FADH2. It will give FADH2. So this is one step attack. So now we can see the NAD plus act as a coenzyme during the oxidation of dihydrolipoids to lipoid. The enzyme dehydrogenase oxidizes this conversion of dihydrolipoid to lipoid using FAD as a coenzyme. Oxidation of dihydrolipoid to lipoid. So here the enzyme is used, that is dihydrolipoyl dehydrogenase. So that's what this is C is incorrect option. So NAD plus do not act as a coenzyme during the oxidation of dihydrolipoid to lipoid. So option C is correct here. Okay. Another question we have here is the last question was clear or not clear? Anyone?
Clear, sir.
Okay. The 5-fluorouracil is an anti-cancer drug irreversibly inhibit the thiamidylate synthase. Identify the correct statement from the following. This 5-fluorouracil mimics the DTMP and get covalently attached to FADH2, and the DUMP and get covalently attached to N5-pentan methylene THF. This mimics the DTMP and get covalently attached to FAD or covalently attached to NAD+. So what is the correct option here? Any one of you?
I think B, sir.
B. Okay. Yes, B option is correct. So the 5-fluorouracil is a common anti-cancer drug that inhibit thiamidylate synthase, which uses N5-N10 methylene tetrahydrofolate as a coenzyme. The enzyme reacts with 5-fluorouracil in the same way it reacts with DUMP. Hence, it is a structural mimic of DUMP, which is natural substrate for the enzyme. So here the structure of DUMP. So this is the structure of DUMP. This is N10 N5 methylene THF. Thymidate synthase. This convert this DUMP to DTMP and give this THT DHF, tetrahydrofolate to dihydrofolate. Fine. So this then fluorine of 5-fluorouracil causes the coenzyme to become permanently attached to the active site of the enzyme. So what this 5-fluorouracil, it mimic the structure and then it will get attached to the enzyme. This is the enzyme attached. This is the 5-fluorouracil. It will get attached to the enzyme. So this fluorine is too electronegative to eliminate it as a F plus. Consequently, the reaction stop, leaving the enzyme permanently attached to 5-fluorouracil. So if this fluorine is not there now, then this cannot act as this anti-cancer agent. Since the active site of enzyme is now blocked with 5-fluorouracil, it cannot bind DUMP, and therefore DTMP cannot be longer synthesized, and without DTMP, DNA cannot be synthesized. Consequently, cancer cells undergo death. Okay,
Yes, sir.
yeah. So enzyme, it this is enzyme, but it will attack here. Then it will currently get linked. Another question we have this sulfadiazine. Sulfadiazine is sulfonamide based antibacterial drug. Okay. Which one of the following option may be considered the most appropriate region for its antibacterial activity? It mimics PABA, mm, paraminobenzoic acid, and reversibly inhibit the dihydropetroyl synthetase. It mimics folic acid and reversibly inhibit the dihydrofolate reductase. It reversibly inhibit the bacterial this pyruvyl dehydrogenase. It irreversibly bind to FAD and stop the acetyl coenzyme metathesis. So which option is correct? Any one of you?
Sir, it's a guess. I think A option.
It mimics the PABA and reversibly inhibit the dihydro. Yeah, that is correct. So here the details. So the sulfonamides act as a competitive enzyme inhibitor of dihydro dehydropetroate synthetase and block the biosynthesis of tetrahydrofolate in bacterial cells. So this is, if you see, this is the substrate, this paraaminobenzoic acid for synthesis of dihydropetroate. So if you use this sulfonamide, this this will block the activity. Join. Okay. So due to structural similarity of this sulfonamide acts as an inhibitor by mimicking the paraaminobenzoic acid, one of the normal substrate for dihydropetroate synthesis. This is the mechanism for synthesis of this dihydropetroate. This dihydropetroate synthetase will take this paraaminobenzoic acid and it will ligate with uh, this paraaminobenzoic acid. And then what will happen? This glutamic acid come and it will get attached to the and form the hydrofolate, and this dihydrofolate will this dihydrofolate acted and NADPH mechanism, it will form this tetrahydrofolate coenzyme F. So if you have something that can replace this, that is sulfonamides, and if you're going to replace this, then it will not get further attached because you're going to replace this end do not have any SD group, right? This group do not have any SD group, so it will not get ligate to here with the glutamic acid, so this mechanism will stop. So answer is correct. Okay, so next is with reference to mechanism proposed by Professor P. Dot. If radioactive oxygen is used during the vitamin K2 catalyzed carboxylation of glutamate, which of the following species will act as a strong base responsible for the abstraction of gamma hydrogen atom? So we need to first know the mechanism, right? So base will abstract the proton, and then base will abstract the proton. This negative charge will come and then will attack to the oxygen. This oxygen, this negative charge will again attack to this carbon. It will make this O negative. So again, this will O negative will attack and it will form this peroxide bond. It will form this epoxide kind of structure, and then this vitamin K base. It will abstract the proton. It will provide the proton from here. It will be uh, this gem diol, and then again it will this negative charge will attack to the CO2 and will form this gamma carboxyglutamate. So correct answer is C. Someone wanted to join now. So correct option is C. So this species was formed, if you see, in the mechanism this species was formed. Question is saying that KH2 catalyzed carboxylation of glutamate. Which of the following species will act as the strong base responsible for the abstraction of the gamma hydrogen atom? So if you see, this is the gamma hydrogen. This hydrogen is the gamma hydrogen, and this species, if you radioactively label it, that is label with this green color asterisk. So these two are the labels, and it will abstract this gamma hydrogen. So this species is formed. So you can see the option C is correct. Fine. So next question we have.
Excuse me,
Uh,
sir.
yes.
Sir, I have a doubt with regard to the NPTEL exam.
Yeah, yeah.
Uh, do we have to learn all the structures and formulas of this, or basic is enough?
I think if you understand the concepts, then it will be pretty much of it. So sometimes,
So for
yeah, remembering the structures also will help. Otherwise, if you do not remember the core structure, then how you will apply your basic formulas? So that is important.
okay, sir, because for the vitamins lecture, she had told that few remembering a few structures is enough, and the rest of it just know how it works.
Yeah, that
So
is
which
that
and
is
all is like.
yeah, that is true. But still, basic structures one should know, right? So
Okay, sir.
So next question we have the one carbon unit for formation of N5 N10 methylene tetrahydrofolate is mostly obtained from which of the following conversion? So this methionine to homocysteine, DTM, DTMP to DUMP, 3 phos 3 phosphoglycerate to serine, serine to glycine. So option D is correct. So once serine is converted to glycine, then it will generate this formal group, and this tetrahydrofolate, it will get converted to NN methylene uh, tetrahydro, tetrahydrofolate. So this condensation kind of mechanism will work here, and this is a formaldehyde. So this will serine will get converted to glycine, and it will liberate this CH2CO. This HC double bond OH. This formaldehyde. Then N-methylene tetrahydrofolate it will form. So next question we have vitamin K is a coenzyme required for synthesis of matured form of certain proteins like prothrombin by incorporating carboxyl functionality to L-glutamic residue in immature prothrombin. Mature prothrombin is represented by which structure? So it is asking the mature prothrombin. So here is the solution we have. The immature prothrombin has 10 of the glutamyl residue in the first 42 residue from the amino terminus. In mature prothrombin, the glutamyl residue is mutated as a Y-carboxy glutamyl residue. So this is the glutamyl side chain with the enzyme vitamin Ks2. In presence of CO2, it will get converted to this gamma carboxy glutamate side chain, and this then it will bind to the calcium. So the gamma carboxyl glutamate residue are good as good chelator for calcium 2 ions and provide the specific CO2 prothrombic complex required for the binding of this phospholipid surface. So option A is correct. So okay, next question we have: which of the following species is most likely to be involved during the following enzymatic transformation? This is the acetyl coenzyme with the carbonic acid, presence of acid ATP. This will get attached and it will replace this ADP and HPA4. So, which of the following species is involved during the following enzymatic transformation? So, let's see. Acetyl coenzyme carboxylase converts acetyl coenzyme A into mono malonyl coenzyme A. It uses biotin as a coenzyme. Biotin used this bicarbonate HCO3 for source of the carboxyl group that become attached to the alpha carbon of the substrate. The mechanism involving carboxy biotin is here. This is bicarbonate. This is adenosine phosphate. Adenosine triphosphate. This bicarbonate will attack to the phosphate activated bicarbonate with the mixed anhydride, and then again this so enzyme bound biotin, it will be this inolate kind of structure. It will come and this will attack to the this carbonate. It will form this kind of structure. Again it will release this phosphate, and then this carboxybiotin will form. This carboxybiotin inolate of this acetyl coenzyme, it will attack to the carboxy. It will form this acetyl coenzyme, and then the acetyl coenzyme will get attached to the biotin, and then it will get back to the malonyl coenzyme. So this biotin is involved. So option D is correct here. Okay. Consider the following reaction and identify the correct statement. This methyl malonyl coenzyme get converted to the succinyl coenzyme by using this methyl malonyl coenzyme mutase enzyme vitamin beta. The reaction is expected to be quenched in presence of TIMPO or radical scavenger. The reaction follows the sigmatropic rearrangement. The oxidation step of cobalt always remains 3. The reaction involves the fission of cobalt oxygen bond. So, which is the correct answer in this cases? Let's see. The correct answer is A. The reaction follows free radical pathway since tempo is an established scavenger, so that expected to be stopped. So this reaction follows this free radical pathway, so tempo is a tempo radical scavenger and it will stop the reaction. So option A is correct. So if you see the mechanism of the tempo, here the tempo, then adenine used to attack this homolytic cleavage, it will generate this radical, and then this radical will strike this proton, generate this radical. Again, it will form this proton will get transferred to this C carbon, and then this radical will generate. This radical will attach to the carbon. This cyclopropane type of ring will form, and again it will get open to form this steel coenzyme open form. It will again abstract the proton. This is the mechanism, and in all the cases, this cobalt 3 remains in cobalt 3. So no, cobalt 3 get converted to cobalt 2. Yes, so it do not remain in the cobalt 3. So that option is incorrect. So first option is correct over there. So next question we have: consider the following truncated representation of NAD plus. Which of the following atom is most susceptible towards receiving the hydride ion during the reduction of NADH. Which of the carbon atom is most susceptible to receive the hydride ion? This is A, this is A, B, this is A, this is C, this is D. So let's see. A. The carbon A is the most electrophilic center as it is conjugated with the quaternary nitrogen, which act as a electron sink. Yes. So if the hydride will get transferred from here, then it will come here, and the electron will get absorbed at the nitrogen plus center. So this is the most electrophilic center, carbon A. Option A is correct. Any doubt on this to any one of you?
No, sir.
Yeah. Okay. So next question again we have among the various hydroxyl hydro hydrogens, the one that is most likely to get exchanged at the fastest rate of with deuterium when the following molecule is resolved in D2O. So very basic question. So among the various hydroxyl hydrogen, the most that is most likely to get exchanged at the fastest rate of deuterium rate with the deuterium when the following molecule dissolve in D2. So basically, it is asking which hydroxyl group hydrogen is having more acidic. Which is more acidic?
Option B, sir.
Option B means hydrogen B. Okay, so let's remove all of them and see which one is more acidic. So right, this is O, right. This is OH. I'll remove this first. This is OH. This O minus. Right, option B if you remove H. OH. Okay, and if C is removed, then it will be O minus OH. OH and OH. In the same way, if you remove these two minus, this will be minus minus. So which will be more acidic? Let's say this is removed. So in this case, if this is stabilized by any kind of conjugation, this negative charge is stabilized. This one not stabilized. So if you remove this one, see if you remove this one, right, form negative charge, this O minus, right. So this O minus, it will get into the conjugation and stabilize. In the same way here it is shown. And in no other cases this will get stabilized. So option B is correct. Is it clear to everyone? Yes, you're
Yes,
right.
sir.
Option B is correct. So next question we have, which one of the following sentences identify or sentences regarding NADPH? It's incorrect. Apart from the hydride donor moiety, the rest of the structure shows coenzyme to be recognized and bound by the enzyme. The absence of enzyme, the reduction process becomes very slow. In absence of enzyme, the reduction process becomes very slow. There is no stereoselectivity in NADPH mediated reductions. It is protein molecule nucleotide coenzyme. So which option is correct here?
Option D was the incorrect, sir.
Option
D. It
it
was a pyridine nucleotide coenzyme.
is a protein nucleotide coenzyme. So in this case, option C is correct. There is no stereoselectivity in NADPH mediated. So, okay, option D, that is D option means it's protein nucleotide coenzyme. That is correct. So option C is incorrect. So an enzyme that
Yes.
catalyzes the reaction can distinguish between two hydrogens at the fourth position of the nucleotide ring of NADPH. So these are the two hydrogens HA and HB. An enzyme has a specific binding site for the coenzyme, and when it is bind to the coenzyme, it blocks one of its side. If the enzyme blocks the B side of the NADPH, the substrate will bind to the A side of the HA hydride and will be transferred to the substrate. If enzyme blocks A side, the coenzyme, then substrate will have to bind to the B side, and SB hydride will be transferred. So there is no stereoselectivity in NADPH mediated reactions. Option C is correct. So other options are correct statements. Okay, let's talk a little bit about sugars. What are the main functional groups present in carbohydrates? Alcohols and carbonyl groups, hydroxyl group and amine groups, aldehyde and ketone groups only, carboxyl groups and amine groups. Answer please.
Option C was the correct one.
Aldehyde and ketone groups only. Okay. Anyone else?
Option C was the correct answer, sir.
Option C. Aldehyde and ketones groups only. Okay.
Yes.
Option A is correct. So it do have alcohols and carbonyls. In carbonyl it comes aldehyde also. This is R H and this is R1 CO R2. This comes under the carbonyl group. So what is attached here? It doesn't matter. This functionality called carbonyl group. So this carbohydrates do have hydroxyl and carbonyl group, right? Like in glucose, it is aldehyde and hydroxyl groups. It do not have amine groups. Option A is correct. Which of the among the following is not an aldohexose? Glucose, fructose, mannose, galactose.
Option C, mannose.
Mannose. Okay. So it is asking aldohexose. So aldo correspond to aldehyde and keto. There are two types. Ketohexose and aldohexose. Ketone. So aldehyde structure will be R CO H. Ketone will be R CO, this R2 and R1. So glucose, it's aldohexose or ketohexose. This aldohexose, it will have an aldehyde as a functional group. Ketohexose, it will have a ketone group as a functional group. So glucose is a aldohexose or ketohexose.
Aldohexose.
Aldohexose, right? So glucose has having aldohexose. Fructose, what will have? Aldo or keto?
Aldohexose.
Fructose. Mannose. Okay, then let's see the structure of glucose, fructose, mannose, and galactose. So here aldo and keto prefix identify the nature of carbonyl group. OH suffix distinguishes the carbohydrate. Number of C's in the monosaccharide identified by this tri-tetrapentahexo. So glucose and aldohexose. Fructose, it's a ketone group. This is ribose, again aldohexose. This pseudoheptulose is again a keto group. So, and this mannose and galactose also contains aldohexose. So fructose is a correct option here. So these kind of questions will come. They will ask the functional group. Option B is correct. Which among the following is a pentose sugar? Glucose, fructose, ribose, galactose.
Ribose.
Which one? Ribose. Ribose?
Yeah. Yes, sir.
Yeah. Ribose is correct answer. So here the structures are given of this ribose, tagatose, picotose, defructose, D-allose, glucose, mannose, galactose. So you can see this mannose also have aldehyde. This also have aldehyde. Fructose is ketone. These groups are having ketone containing. These groups are containing aldehydes. The reference compound for the naming D and L isomer of sugar is fructose, glyceraldehyde, ribose, glucose. So if we start the D and nomenclature, so what is the reference compound for nomenclature of D and L? Anyone of you?
Glucose, sir.
No, it is ribose. So D, L and D refers to absolute configuration of a sugar. A sugar is assigned as L or D depending on whether the highest numbered stereocenter matches the configuration of L or D glyceraldehyde. Okay. So if the bottom-most chair center in the Fisher projection has the hydroxyl group on the right and the assigned the descriptor D. So if it is on the left, then it is assigned as L. So if it is on the right, if we see this is aldehyde, if it is on right, D, left, L. The enantiomer of D sugar is always in L sugar, vice versa. D and L not different direction in optical rotation. So it will be on the basis of glyceraldehyde. So this is D-glyceraldehyde and L-glyceraldehyde, D-glyceraldehyde. It is always nomenclature based. This parent molecule is D-glyceraldehyde, L-glyceraldehyde. So alpha and beta. So refer to the configuration at the anomeric carbon C1. So for these sugars drawn the standard way, the alpha anomer has C1 OH pointing down and beta anomer has C1 OH pointing up. So this is C1 position and this is pointing up, pointing down. So if you see this 2OH 1 and 5 are in the same uh, opposite phases. So this is alpha. If it is in the same phases, this is beta. Carbohydrate that have a different stoichiometry, only one carbon atom are called apimer, anomer, constitutional isomer, and enantiomer. So what is the correct answer?
Option D, sir.
Option B, anomers.
Option D, enantiomers.
No, enantiomers are the non-superimposable mirror image. However, these carbohydrates they do not have have the mirror image. So option A is correct. They are epimers. Anomer and epimers. The stereoisomers which differ in the configuration at only one carbon atom are known as epimer, whereas those which differ in configuration at acetal or hemiacetal carbon are known as anomers. Okay, so it is epimer. So anomer are cyclic monosaccharides or glycosides that are epimers. So epimers and anomers both are similar, but if it is cyclic, then it will be called anomer. If it is non-cyclic, then it will be called epimer. The aldose are in the configuration C2 if they are ketoses. The epimeric carbon in anomer are known as anomeric carbon or anomeric center. So here is the anomeric carbon if you can see. So this is the anomeric carbon here. The configuration is changed in this position. In this case also. The structural representation of cellulose is shown below. So choose the correct statement bond joining the monosaccharide units. So it is asking this linkage, what it is called. Alpha 1,2 glycosidic bond, beta 1,6 glycosidic bond, alpha 1,6 glycosidic bond, beta 1,4 glycosidic bond. So if we know the naming of the sugars, so you can start from 1, 2, 3, 4,
Option B was the correct answer.
5. Option B 1,6. So let me
Beta 1,6 glycosidic bond.
okay, let me name 1, 2, 3, 4, 5. Now you tell. So here the 1 position is connected to the 4th position. So it is 1,4, right? So it is beta 1,4 glycosidic lactase. The beta 1,4 glycosylate in the all this structures, it is not connected to 1,6. Fine. To form a pyranose, the hydroxyl group from which position of aldohexose attached to the carbon C2, C6, C4, C5.
C2, sir.
C2. Then is C5 also how? So this is the structure of glucose. So if you number this carbon 1, 2, 3, 4, 5, 6. So the fifth carbon hydroxyl group attached to the carbonyl group of one carbon. Then it forms this glucopyranose. So which carbon attacked? C5. Then it forms cyclic structure. So you can draw this to this chair form. So this is an HCl and this NMR of this one is equatorial. Same with the fructose. So C5 is correct answer. Furanose sugar are comprised of 4-member ring, 5-member rings, 6-member rings, 7-member rings. Furanose. Hey, pyranose. I told you pyranose. No, furanose.
5-member ring, sir. 5.
5-member. Right. So furanose are 5-member. So glucose can adopt to 5-membered furanose form in addition to 6-member pyranose form. So if it is attacking from here carbon 4, then it will form 5-member. If it is attacking from carbon 5, then it will form 6-member. So furanose comes from furan. So pyranose, furanose, and ring chain tautomeragon. So they exist in equilibrium between their open chain and Bayes closed chain form. So this is the open chain form. It is found 0.2 0.02%. This is pyranose form 99%, and this is less than 1% furanose form. So you can see if this attacks here, then this is pyranose. If this attacks here, then this is furanose. Okay. So next question we have, which structure among the following is correct to representation of D-glucopyranose in a Haworth position? Haworth projection, which one is correct structure? Option A is correct. So This is the correct structure of this D-glucopyranose. So our projection of D-glucopyranose is given here. So this is D and L pyranose. So next option answer we have the different stereoisomers formed due to cyclization to aldehyde are called epimers, enantiomers, constitutional isomers, enantiomers.
Anonymous.
Enantiomers, right? Yeah, enantiomers, right option. Which of the following is an endomeric pair? Alpha D glucose and alpha D mannose, alpha D glucose and beta L glucose, alpha D glucose and beta D glucose, alpha D glucose and alpha L glucose.
Option D was the correct answer.
Option C is alpha D glucose and beta D glucose are the endomeric pairs. Okay, so stars and glycogen are the both are polymer of
So, option
fructose, sucrose, alpha D glucose and beta D glucose.
sucrose.
Sucrose. So this is the polymer starch and glycogen, both of the polymer of alpha D glucose, not for sucrose. They are bound together by glycosidic bonds. Which of the following statement is true for the cyclic structure of monosaccharides? They form acetals, they form hemiacetals, they are ethers, they are esters. So first tell the what the chemical structure of acetal, acetal, hemiacetal, ether, ester. What the structure of acetal? This is the acetal. This is hemiacetal. This is ether. This is ester. So in monosaccharides, which of them are formed? Acetals, hemiacetals, ether, esters.
Hemiacetals.
Yes, right. You're right. They form hemiacetals. So if you have a ketone, always alcohol will attack and form first hemiacetal. Another molecule will form acetal. Carbohydrates that are optically active have the ability to rotate the plane polarized light. Light rotated in the clockwise direction is generally represented by symbol Lr plus alpha.
Plus
Yeah, plus. The main component of the plant cell wall is cellulose, glycogen, peptidoglycan, lignin. It is a cellulose.
cellulose.
Yes. Plant cell wall mainly consists of cellulose. And the questions we have, which of the following act as a storage form of high energy phosphate? Glucose 6 phosphate, phosphoenol pyruvate, this phosphadines, glycerol phosphate. So option C is correct. Yes,
Roll call.
phosphadines.
Okay, sir. Okay.
What is the standard free energy change of ATP? It is small and negative, large and negative, small and positive, large and negative. So the change in the standard free energy uh, ATP is large and negative. So option D is correct. Which of the relationship between delta G and delta G naught is correct? Delta G is equal to delta G naught plus RTLN product upon reactants, or which equation is correct? Correct. Yeah.
Option B, sir.
Option B.
Option B was the correct answer, sir.
Okay. Let's see. Option A is the correct one. Delta G is equal to delta G naught plus RTLN. Okay, so another question, we have a biochemical reaction. A transform to B has a large and positive change in free energy. Delta G is equal to greater than 1 under the physiological condition. Which of the following is the best estimate for equilibrium constant K?
Option D, sir.
Option D. K is greater than 1. So okay, let's see. So delta G naught is equal to RT minus RT and KQ. The equilibrium constant and delta G naught. When the reaction coefficient is lesser than the equilibrium constant, chemical reaction will proceed in the forward direction. And equilibrium reach Q is equal to K. However, Q is less than K, the process will proceed to reverse direction. Equilibrium will be achieved. Free energy change for a process may be viewed as a measure of driving force. A negative value of, so what it is saying, a negative value of delta G represents a finite driving force for the process in the forward direction, while a positive value represents a driving force for the process in the reverse direction. So what it is saying here, delta G is a positive. Delta G, okay, delta G is greater than 1. That means the positive value. So it is saying this positive represents a driving force for the process in the reverse direction. So the process will be in the reverse direction. So if the delta A to B and is a KEQ, if the delta G is positive, so the process will be into the backward direction. So that means KEQ will be towards negative. So it will be lesser than 1. So option B is correct. So here, I mean, few points like if K is greater than 1, delta G is less than 0. If K is less than 1, delta is greater than 0. So these both are opposites. So option B is correct here. Which of the following is an inorganic substance that is tightly bound to enzyme and required for their activity? Coenzyme, prosthetic groups, NAD, vitamins. Which option is correct over here?
Prosthetic groups.
Prosthetic group, right. Biologically, which of the following has the highest redox potential? Carbohydrate, proteins, oxygens, lipids. Highest redox potential.
Oxygen, sir.
Oxygens, right. So metabolism is best defined as the breakdown of glucose with the release of energy, the build, building nucleic acid with the input of energy, the breakdown of proteins into amino acids. Option first and second and third is correct. First and third, first and second, first, second, third, all are correct.
Option D, sir. 1 second and third.
Option D, yeah, all three is correct. So this intersonic reaction requires energy overall, release energy overall, proceeds spontaneously, does not require any activation energy. So what you have see on that? Yes, it requires energy overall. A hydrolase joins two molecules together using energy from ATP, transfer part of one molecule to another molecule, split a bond by adding a water molecule, remove a group from molecule forming a double bond, or adds a group to double bond. So which option is correct? Hydrolase, about hydrolase. Simple. Which option is correct? So
Option C, sir.
yeah, it splits the bond by adding a water molecule, right? Its name is hydrolase. Which of the following electron carriers is not able to transfer one electron at a time? NADH, FMN, FAD, ubiquinone. So this NADH,
FAD, sir.
NADH.
Adenine. Tiny.
Reduced QS2 is not found by which of the following? Complex 1 and NADH, complex 3rd and cytochrome C, complex 2nd and succinate oxidation of glycerol 3-phosphate. Option B is
Option D, sir.
option B, complex 3 and cytochrome C. If electron transfer is tightly coupled mitochondria is blocked. If electron transfer in tightly coupled mitochondria is blocked with antimycin A, between cytochrome B and cytochrome C, then ATP synthesis will continue, but the PO ratio will drop to 1. Electron transfer from NADH will release, but O2 uptake will continue. All ATP synthesis will stop. Electron transfer from succinate to O2 will continue unabated.
Yes, sir.
Option C is all ATP synthesis will stop. Mitochondrial ATP synthesis is being done in mitochondria, right? When delta G naught of the ATP synthesis reaction is measured on the surface of ATP synthase enzyme, it is found to be close to zero. This is likely to due to a very low energy of activation, enzyme induced oxygen exchange, stabilization of ATP related to ATP by enzyme binding, stabilization of ATP related to ATP by enzyme binding. Option D is correct. So stabilization of ATP related to ATP by enzyme binding. The relative concentration of ADP and ADP control the cellular rates of glycolysis, oxidative phosphorylation, pyruvate oxidation. Here all the processes are controlled by ATP to ATP. Concentration of ATP and ADP. Okay. So that's all for today. Thanks a lot for joining. Hope to see you into the next session. That will be the last session for this course.
Thank you.
Thanks a lot for joining.